Yay, let's get started. Hello. This Monday is the legend of data time, and it's another hot summer day in London, and I'm super excited because I'm literally going on holiday after this streaming. So finally, I need a holiday, and everybody was on holiday the week before, and you know, because they said that there's going to be a second wave, so that's the only kind of tiny window that you're allowed to travel. Of course, I have like all my face mask with me, so I'll try to be safe as well, but also enjoy to get away for a little bit. Cause yeah, it's really difficult if like, cause I love travel. It's like really difficult to be not traveling and try to, I love doing stuff that I'm doing during the quarantine or the lockdown, but still I miss the time that I travel. And that's why like Meet Me Pie would actually try to see if we can stream overseas. But yeah, I'm actually like traveling with Lace, my friend, who also do the show Meet Me Pie with me on Wednesday. So we'll see if we can stream. But if not, then I will just enjoy our holiday. I will let you know in my Twitter. So follow me on Twitter if you haven't done it. So you will know when things like this, sudden like accident happen, that I can let you know what's going on, so you won't be like here waiting for me to go live. Okay, so um, oh yeah, yesterday actually, like I want to chat a little bit more before we start. So yesterday we had our data science workshop in PyCon Africa, and it's amazing that people who joined really enjoyed it, and it's just a very nice atmosphere. And also there are like mentors who are asking, like they want to be back, they want more. So that's really good. I feel like we're building a community. Although there are some technical issues, well, the participant, a lot of them like didn't show up, or didn't show up on time due to various reasons. It may be the internet or the power even, it's not working well for them. So it's always a challenge that I think that even though, we think that going online it could be more accessible, but still in some places it's not as accessible as we think, because people, the internet is really important for them. Like if it's, we can't use our standard to think about those places. And so I don't know how to help. I want to like really like do more stuff in places that information is not that accessible and not that easy to acquire. And I really want to help the people there with, I think, you know what I can help is like some software thing. I really like can help with hardware thing that you need the local community there to like, or the government there to do something to provide infrastructure for them. So yeah, but I see like very creative way, for the community in Africa to do things. Like they have ideas of, this call they call it sneaker net, that I learned about last year in Namibia, that they kind of have a USB or have a device that they kind of like they pass from one to each other. So it's kind of like, instead of having an internet, they would pass on information by having a device that they would share information from one person to another. So that's very creative. And also other things that they do like in Python Africa, there's the talk about putting the PyPI, the whole Python index, into a Raspberry Pi, so you can bring it around and provide it. When you are teaching Python or doing a workshop, you can give people the tool to do it. So that's really great. I think this is very creative of like combating the problem of not having a reliable internet, and we should really learn from them. So, okay, chit chat is done. So let's go to our tutorial today. So before I started talking about decision trees, I want to clear one concept first, is the difference between supervised learning and unsupervised learning. There's also kind of a middle ground of semi-supervised learning, but I won't go into detail in that area. I'm just going to um, tell the like sometimes like it's good to explain these terms. It's difficult to just like spend a whole episode explaining like some of these terms. I'll just like slide them in, when we go. So supervised learning actually is, well, is a task that machine learning task that the data that you use to train need to be labeled. So you have to. So this is a very good explanation in the Wikipedia. You have to have an input and output pairs. So So things need to be labeled as yes or no, or labeled, with a value, or labeled with different categories. So you have to provide an example for the machine to learn. Okay. Um, so that includes a lot of algorithm actually. Um, so like a lot of times that we if you have a chat with someone who is working in data science, then they will be like, oh yeah, getting the data is the problem, or the data quality is the problem. Well, that actually it's mainly because a lot of algorithm, they're very reliable and very powerful algorithm, they rely on this labeled data. Okay, so they are supervised learning models. They need a lot of good quality data that is labeled correctly, because like we need a lot of data, and then like you need to have human effort to to acquire this data. Sometimes it could be done by a survey. You can ask people to help out. This usually, well, that's the challenge. Like if you have volunteers to help you to label these, to provide this data, then the quality of it is also difficult to control. Okay, so for example, I've done something with Mozilla projects that they want to have well they actually the project is more complicated than what we're talking about now, that they're doing some like kind of voice recognition, like kind of NLP stuff. So they need a lot of people speaking some sentences in the language. So like the language that I was helping out was my mother tongue, Cantonese, and well they're quite, it's not a super big language like Spanish or Mandarin, but it's still a lot of people, as a big ethnic Chinese population is speaking in Cantonese, and yeah, so it's well, I just appreciate that they have this. They are not ignoring my mother tongue as a language, and so I do that, and I have to record, saying those sentences, but I can also be the person who are labeling those sentences. So like I have to verify that um, those sentence that is recorded by someone, a stranger, that is say correctly. So I have to label them. So yeah, so well, you can pay for someone to do that. I know that Amazon, there's a service called Mechanical Turk, which we always joke about. Like, oh yeah, your algorithm is not smart enough, so just like hire the Mechanical Turk to do the job for you. Just use human brain instead of the computer. So yeah, that's actually like they're hiring people in. So like we are saying that they are hiring people, which at a country that labor is relatively cheap to do this labeling. So of course they provide training, so the quality is controlled, but still it's always a problem to get a good cleaning data, and this data quality actually affect how good your trained model will be. So yeah, that's always the problem with supervised learning, and that's why there's always, whenever, there's a task and there's a algorithm, there's supervised learning algorithm that could achieve those tasks, and people always look for whether there's an unsupervised learning method to do that. It applies to some of these, NLP stuff, because it's super difficult to label everything in language. So they seek for some algorithm that is super smart that could do unsupervised learning. Um, or semi-supervised learning. Just try to get a middle ground of it. So unsupervised learning is the other side of the picture. So it's the opposite. So it's the machine learning that doesn't require labeled data. So you don't have to hire someone, or like hire people or ask for volunteers to help you to label them. It's just that the nature of the data that you have, like for example, you have a bunch of measurements of let's say a bunch of measurements of a plant, and then actually you can group them into like different groups. Let's say that maybe the length of the leaf, or the ratio of the length and the width of the leaf, and all these like, and then those can actually let you to put them into different categories. So you may not know what category that is. That would require some labeling, right? So there will be some botanist or like expert to like, oh yeah, this is a leaf of like of roses. This is a leaf of, I don't know, um, broccoli. um, so yeah, so the data itself are not labeled, but because of the characteristic of those data, that you can actually separate some from each other and get some useful information out of it, then that's unsupervised learning. So that you can see the example that I have made is actually they involve clustering. That's actually a lot of unsupervised learning is actually involve some clustering method in there because that's the most straightforward. Of course, there are more like other very complex unsupervised learning algorithm out there, but they are super complicated, and you may have to do like if do some like research to understand them. So I'm not covering them here. So yeah, so by clustering the data, that actually you can train a model to actually classify different new data points according to well the previous clustering. So I can this new data together with all this group. So like this new leaf that I got, and after measuring it, and I could be like, okay, even though I don't have anybody to label it as a label the other example for me that is a rose leaf, but it kind of look like all these leaves that I picked from a rose there, so it's a rose leaf. Okay, so yeah, so it's kind of work like that. um so let's go back to the start of today. The topic that we're talking about today is the decision tree. So um yeah, so this is what I was talking about last week, that we are making decisions. So it's kind of like a human making decisions, looking at some of the features that you provide and the result of it, so the labeled answer of it, and try to determine whether you can make some decisions based on the statistic of each features, like and the outcome, of course. So yeah, so uh, I would just like briefly go through this. So this is actually a data from the Titanic dataset in Kaggle. So if you're curious, you can download it there. You just need to have a Kaggle account, which you can register for free. Um, so the first thing that we look at is that, judging from all the data that we got, then I think the most important, so the first question you ask whether these passengers survive is that a male passenger. So if is a male passenger, then the chances of surviving is actually not that high. And so okay, so if that's a mouse, so if it's not a male passenger, that like you could actually you would just guess, oh, this passenger is probably, yeah, they will probably survive. She will probably survive. Yeah, that's a good guess. And if not, then you have to maybe ask some more questions, like, okay, is that male passenger a child? Okay, is he like younger than 9.5 years? And then if it's a very very young child, then then you can also ask another question. Oh, is there any family members with that passenger? If there is, then you can safely say that, oh yeah, if it's a male, a baby boy with the family, then probably the baby boy will survive. Um, or otherwise, oh, that would be possibly like the unfortunate passenger that died in the Titanic accident. So yeah. So how can we achieve all these things? Um, so let's learn a little bit about the decision tree algorithm before we try them out. So Um, so decision tree algorithm is a supervised learning algorithm. Like I said, you have to have like all these features. For example, the Titanic dataset, you have whether this passenger is a male or female, the age, whether it's in the first class or third class, cabin, or are they with the family. So all these are features, but we have the answer, the labeled result. The answer is survive or not. So that's a labeling. So that's a supervised learning. Um, so it's a predictive model. So it's used to predict an outcome. Even though this outcome could be a classifying outcome, like the Titanic that we had, like yes or no. So it's like survive or not, or is it rose leaf or broccoli leaf or apple leaf? I don't know. Um, so those like classification. But there's also like you can do regressions. You can actually like have a predictive values that's given at the end. So yeah. Oops. So there's a typo here. I don't know why there's extra e, and Yeah. So actually, like, oh yeah, missing an R. Sorry. Represent decisions and decision making. So you can see that we go down the tree, like the previous picture. So it's actually similar to a person's decision making and thinking process. Yeah, so like I said, there's two different outcome that we could predict is whether a classification, so that would be classification trees, or is a regression, so it would give a numerical value as an answer. So I would say the classification is more popular. Like I said, a lot of problems in the practical world uh, are actually classification problems, but you will still came across regression trees sometimes. Um, the good thing about decision tree is that there's no need to create a dummy variable. So because like I said before that because decision tree is like branching out, so you don't have to create a lot of dummy variable. You can just label them as 1, 2, 3, 4, 5 because the ordering doesn't matter because it's just look at different labels whether that make a difference. Whether so for each feature you can just like if it's a categorical data you can just like label them randomly, um, and it would just okay, one is different from two. That's the only thing that decision tree wants from that feature. So it doesn't really matter whether you're one and two, how do you label them. Um, so there's no need for dummy variables really. So that's a really good thing, especially when you have, like I said, the problem that we had last time. If you have a feature that got lots of different classes, so it's a very diverse class. For example, it could be every single country in the world. Well, there's like more than 100 of it. So you don't want to create like more than 100 dummy variables. So that it like the decision tree would really be helpful. Um, Also, there's like feature selection. So this is a very interesting feature that a decision tree or tree-based algorithm could give you is the importance of different features. So you can actually see the feature importance, and sometimes that's really helpful. That's sometimes it's what the business wants. Okay, so I remember when I was working in my previous job that there was a project with a big company that they want to look at, during their extra hour process, that like um, which feature actually important in the in their hiring process. So to see if they have any discrimination and things. So what we do is like we use the result of their hiring, and then we try to mimic it by building a decision tree, not a simple decision tree, but of course like some random forest or another things, and we try to look at the feature that is important, so we can kind of like, so it's not a predictive model, but it's a model that try to figure out like what features are important. And so yeah, that's quite cool. That's a decision tree can tell you that. Because there's another problem with machine learning that people criticize it because, well, it's like a black box. It just gives me a prediction. I don't know how it comes to this conclusion. And for decision trees, well, because it's a tree that is like a human decision process, so you can actually look at how the computer is making a decision, and then you can actually see which feature like is the most important one. So and it performs very well if you have a large data set that is giving a lot of examples, but there's a problem with the single decision tree is that it's not robust. If you have some noises in your data that would actually draw the decision in making like it would really like modify the decision tree in a very weird way, because the decision tree try to be as detailed as possible to also fit in this exceptional cases, and it's actually very good with doing that because it's just like ask some extra questions, then you would get to that conclusion. So it's not very robust and it overfits very easily. So if you have some noises in your training data, and your decision tree will try the best to build as much branches as possible to fulfill those noises, and that create overfitting. So yeah, so we still haven't talked about overfitting and precision and stuff. So okay, so I will just briefly talk about it, and in the future, like I will also slide in some kind of concept thing. Like, so overfitting means that your model actually did a really, really good job in training the data, right? So remember a few episodes ago, I talked about training and testing data, right? So why we do that is that because we want to avoid overfitting, okay? So overfitting means that you have a set of training data that you use to train your model, and your model do a very, very good job of, you know, with providing the same prediction that matches the answer as good as possible, right? So it's very good. It's almost correct. Let's say I give this decision tree 100 training data, and the decision tree is like after some training is very good at providing a correct answer for each of these single like 100 training data. So all of the labels are matching with the prediction. Okay, so that's 100% correct. But it could be an overfit model because when I put in a new data that this decision tree have never seen before, the number 101th um, um, data point, then it will give a result based on these 100 data that I've given it before. Sorry, I was like, I have some sesame in my mouth. So I was having some Japanese salad, so I have some sesame. Um, so yeah, you have to. So it's the decision tree is very good at doing those 100 predictions. So anything new would actually be based on the previous 100 prediction that was given, and it would make it very, it's not generalized enough. So it doesn't generalize enough to allow some room for a new that is unseen data to come in and still would get a correct result. So that's called an overfitting. Okay, we'll talk about it more in the future, hopefully. So, um, yeah, so let's look at decision tree in scikit-learn. So let's have a look by clicking on it. And yeah, because this is a very, very good one that I found. Hopefully my internet is cooperating. Oh, geez. I have some frame rate drop again. I don't know why. Yeah, okay. So hopefully it's a temporary thing. Yeah. I hope it's not because like I keep getting messages from my colleague on Discord. Yeah. All right. So decision tree. So you can see this is a very nice diagram of scikit-learn is providing that you have all these data points, but actually it's a sine curve with some noises. Okay. So the decision tree will try to fit that in, and you can see that yeah, it's just trying to like figure it out. Like, okay, well, so if I have a point like here, so where should the target land? So it should basically land here. So it's trying to mimic it, right? So you can see the blue line here, the blue line here. I hope it's bigger. I like big enough. Okay, so blue line here. That is the depth is only 2. Okay, so this is a very small tree. So like we describe the tree big or small depending on the depth. So a small tree here, uh, the blue line here is actually giving a very rough sine curve, okay? But it's not affected by those noises as very, very much because yeah, it just go like this, okay? But the green one, which is a bigger tree, then you can see that sometimes it's doing a pretty good job, except those time that it encounter a noise, that would just like be crazy. And you can see that this is the non-robust nature of a decision tree, especially for a big tree. Then you would have a problem whenever there's a noise that it would try to fulfill every single thing. And it's if the tree, what it could do is that it would just make the more branches, so make the tree bigger, try to fulfill all the situation that it's encountered, even though it's a noise. Okay. So that's not something that we necessarily want. So that's why we would have other algorithms to do that. So this is basically repeat what I've said before. So you can read it. The link is in the slides. So what I'm interested in is to like really use it. Let's try to use a classifier, and then we can look at how the decision was made. Okay, so we'll try to recreate that tree there. Um, so this is the scikit-learn decision tree classifier. In my experience, I hasn't used it that much because like I said, there are some disadvantage of it, and it overfits very easily. So overfitting is something that we don't want. So it's yeah, so it's quite. So yeah, I don't use it that much, but let's try to do that. So let's go to our Jupyter notebook and create a new one, and let's call it a decision tree. Okay, right. So let's try this scikit-learn tree thingy. And done. Sorry of like the screen flashing because I'm trying to copy this thing. Right, I'll just mhm. So yeah, or we can use our previous example of like of the spam or not spam, but it's fine. We'll just use the example here. And here it's doing something. It's running. I don't know whether you can see it well or not, so I would just make it super big. And okay, so it's done. So we actually like what we're doing here is that we have import the tree like the library here, and then we just use the decision tree classifier, and we feed this sample data. So this is very simple, right? 00 and 11, this is just two dots. Um, and the 001 is like giving an O, and the 11 is giving a 1. So we'll see. And yeah, so it just feed X and Y. So let's see. Oops. Yeah, so we can predict the 2 and the 2, so it will give out 1. Okay. So maybe this is not as interesting as I want. So let's try this iris data set, okay? So yeah, just replace this, and actually I'll replace this whole thing, and we will see. By the way, this iris dataset is actually a measurement of different irises. There are three species of iris. This is a very well-known open data for teaching. But and then my friend was like complaining that the history of where it came from actually is from a guy who is by today's standard is very discriminative, so it's not good to use that data set. I was like, okay, we change it someday to not use it, but we're still using it because it's come with scikit-learn. So that's this classifier. It comes with something called a plot tree. No, actually it's the tree. This library here is come with a plot tree. Um, uh, plot tree method that you could plot the tree of a. But I think you need to have graph. Yeah, whoa. Okay. That's very interesting. So, oh, sorry, it's a bit of a mess here. Okay, maybe I will show you the picture in the website, but you can see that. Yeah, this is actually creating like something that it can be put in. Yeah, it could be put in a graph. Yeah. So let's look at a more presentable picture, but it's still too small, and I hope the one that I do it myself is better, but it's not. So let's see if we can. Oops, nope. How can I make it bigger? Hmm. Okay, so maybe I'll just like briefly talk through what's going on. So it's just like saying that the first box here is just like if the third column there is less than 0.8, then okay, make some decision that like this is actually this three colors, the three different um, irises. So if the first one is very easy to separate, but the second one is a bit like the green and the purple are more difficult to separate. So yeah, you can see that yeah, you can use Graphviz to make it bigger, and you can export this data this graph somewhere. Okay, this is much better. Great. So yeah, you can see that okay, so it's the paddle length that is measuring. So it added the label there as well. Okay, so yeah, this is super ugly. Like I don't know what it's talking about. So okay, let's look at this one. So the paddle length, if it's like smaller than some value, then um yeah, it goes other like measure like kind of decision making like matrix here, and So yeah, it will classify, if it's true, they will classify as one type, this genie, so this one type of the iris there, I think. No, yeah, it's still very complicated to see. So yeah, you can see that like this is how it kind of makes some decision. Also, no, this is like Celosa. Celosa, yeah, this is one type of iris, is the Celosa. So this is the orange one. The green one is versicolor, and the purple one is Virginica. I can't be a botanist or like a biologist. I'm so bad with names. So yeah, so you can see that like this is how the decision is made. So it's just like oh, the measurement greater or smaller, and then I kind of like have a vector there as well. So it's quite complicated how a computer think. And yeah, different measurements, petal length, petal width. Yeah, so that's how it does. And it is another way of presenting it, by putting different graphs with different measurements against each other, and you try to like separate them out. Okay. But decision tree is making like you can see that it's making a cut, right? Because it's greater than or equal to some value. So you can see that when you see graph like this is not by anything like a support vector machine or things like that, because you can see that the line that is separating them, a straight line, vertical and horizontal. So that's actually a characteristic of a decision tree, because you're doing it like step by step. So it's kind of like cutting a cake like this and like this, like this, like this. So yeah, so you can actually, yeah, sometimes you can tell by just looking at all these like representation of the results, then you actually can tell what algorithm it is using. So this is interesting. There are more like example like this in Scikit-learn that you could look at. Um, yeah. Oh, so this is a better representation.